Today's lesson is entitled Solving Quadratics Using the Square Root Method. So today we're going to look at simplifying square roots because we haven't really done this before. So the first question is, what is a radical expression? A radical expression is any expression that contains a radical. Well, this is slightly vague. It doesn't help me very much. So what is a radical? This symbol right here is called a radical. The number underneath the radical is called the radicand. And the little number, this n, over here in the groove, is called the root index. Now, a radical is simply a way to undo a power. So if you raise something to the 10th power, and you wanted to undo that 10th power, you would take the 10th root. Okay, now when there isn't a number there, that there's not an n there, we call that a square root. So over here in this third box, whenever there's not a number out in front, that is considered to be a square root. And that's what we're going to be working with today, is square roots. So down here, finding the square root of a number or expression is the inverse operation of squaring a number or expression. So for example, the square root of 4 equals 2 because 2 times 2 equals 4. So it's taking that idea of 2 to the second power and doing it would be 2. Same thing with the square root of 16 equaling 4. Because 4 times 4 equals 16, that would be 4 squared. Undoing that would leave you with the 4. Or the square root of x squared equals x because the square root undoes the power there. Now it's important to realize that we could have said that the square root of 4 equals negative 2 because negative 2 times negative 2 equals 4 as well. So this leads to the next point, which is that a positive number has two distinct roots. One that's positive and one that's negative. The positive, also called the principal square root, is denoted by the square root of a. So they're not going to have a number out front. It's going to be understood to be positive. If they want the negative square root, they're going to put a negative sign in front of it. Okay. Now the most important thing to realize is that a negative number has no real square roots. And this is because there's no way to have the same number equal the number. So for example, the square root of negative 4, if I was to break this up into its factors, this would be 2 times negative 2. And since those numbers are not the same, I can't take the square root of negative 4. It doesn't give me a real answer. Okay, so there are answers out there that would work, but they're not called real. They're called complex. And we don't get into that until Algebra 2. So for us, if anytime you see a square root of a negative, not a real answer. Okay, so down here on number 1, it says the square root of 49. Because it's understood to be positive, that means that we are just wanting the positive root, and the square root of 49 is 7, because 7 times 7 is 49. Now on number 2, we have this negative out front, which means we want the negative root. So this is going to be the square root of 81 is 9, and they want the negative root, so negative 9. Now on number 3, this symbol, this plus and minus, means that they want both roots, both the positive root and the negative root. So the root of 100 would be 10, and then we can either just put a plus and minus out front, like the original symbol has, or we can say that this is the same thing as positive 10 and negative 10. And I don't care which way you write it. I typically write plus or minus 10. It's a little bit shorter, but if you want to write out both answers, that is okay as well. So on number 4, they want the negative root, and the square root of 1 is simply 1. So notice all 4 of our answers on 1, 2, 3, and 4 were nice whole numbers, those integer values. These are called perfect squares. Now, you need to memorize this box of perfect squares. These are the perfect squares from 1 through 15. Okay, so you need to know them by heart. Some of them you probably already know. So for example, 1 through 4 up here, you probably knew those without having to use a calculator. You need to do these without a calculator, so make sure you know the factors of 1 through 15, those perfect squares. Okay, now, a radical expression is considered to be in simplest form if there are no perfect squares, factors, other than 1 in the radicand. There are no fractions in the radicand, and there are no radicals appearing in the denominator of a fraction. So today we're going to just work with this first one, having no perfect square factors other than 1 in the radicand. And to work with this, we need to have a property. So our product property says that the square root of a product equals the product of the square root of the factors. So what this means is if you have two numbers multiplied underneath the radical, you can break them up and take the square root of each of them, as long as those numbers are greater than or equal to 0, because again, we cannot take the square root of a negative. So, for example, down here on method 1, this uses the product property. So does our second method, but the first method is the factor using perfect squares. So to use this method, you must find the largest perfect square that divides evenly into the radicand. So, for example, the square root of 24. I can rewrite this as 1 times 24, or 2 times 12, or 3 times 8, 4 times 6. So these are all ways I can rewrite 24. And this will allow me to use my product property and break them up into its factors. So the biggest perfect square that divides evenly into this number is our 4. 4 is a perfect square. Now, 6 is not a perfect square, which means we're going to take and use our property and split them up into the square root of 4 and the square root of 6. The square root of 4 becomes this 2. Now the square root of 6, there's no perfect squares in that other than 1, so I leave it. So 2 square root of 6 is the simplified version of 24. And the reason we're writing it like this and not as the decimal equivalent is because this answer is exact, and we're looking for precision in mathematics. So method 2 uses a factor tree, and we often call this the barn method. So it's a little silly, but sometimes silliness is what you need to remember things. So you have to imagine that the radical is a barn. So this radical here of the 27 is a barn. And we take 27 and we break it up into all its prime factors. So we're going to do our factor tree. So 27 can be divided by 3 and 9. 3 is prime, 9 is not. And then 9 can be broken up into 3 times 3. So the prime factors of 27 are 3 times 3 times 3, which all multiply to equal 27. So imagine each of these prime factors is an animal. Okay, and they're all the same animal here. In order to come out of the barn, you have to have pairs, because this is understood to be a square root. So it tells me that I need pairs of 2 animals. So this 3 and this 3 are like animals. If they're not alike, you can't pair them up. So this 3 can come out of my barn because there is one factor pair. So notice right here, that 3 came out because it had a pair. Now this 3 had to stay in the barn because it didn't have a pair to bring it out with it. So it stays in the barn all alone, and that is the simplified version of the square root of 27. Okay, and everything I just talked about is in these steps at the bottom here in case you forget. For the most part, we're probably going to use method 2. I think most of you will like that method better, but you are always welcome to use method 1 as well. So down here on number 1, our first problem is going to be the square root of 45. Now we're going to do both methods. So we're going to do the first method, which is to find our biggest perfect square that goes into 45. So if we start going through all our squares, we have, well, let's just think about all the things that multiply to be 45. So 1 goes into 45, but we know there's bigger numbers. 4 doesn't go into 45. 9 goes into 45, 9 times 5. And the very fact that 5 is prime and 9 is not tells me that that's the biggest perfect square. So we're going to have 9 times 5 under our radical. which can then be broken up into the square root of 9 times the square root of 5. The square root of 9 is a perfect square, so we're going to have 3 times the square root of 5, and that would be my answer. Now, if we use the second method, we're going to take the square root of 45 and we're going to break it down into its prime factors. So again, I can still use 9 times 5. 5 is prime, 9 is not, and then 3 times 3. So this would be written as 3 times 3 times 5. So I have to find my couples. So 3 and 3 are a pair. They're the same type of animal. 1, 3 comes out because this is understood to be a square. So 3 times 3 is a perfect square. So I have 3 on the outside. And then the 5 stays on the inside. So notice I get the same exact answer as I did in number 1, but it's a slightly different method. So let's try number 2, the square root of 104. Now you can use either method you want, but with a bigger number you might want to try your prime factors. So we're going to start by factoring this down. And because this is an even number, I know that 2 is going to go into this number. So 52 times 2. 2 is prime, 52 is not. So again, 52 is prime. So 2 times 26. 2 is prime, 26 is not. And that would give me 2 times 13. And we finally got into all our prime numbers. So this is the square root of 2 times 2 times 2 times 13. And I always circle my prime numbers so that I make sure I get them all. It's easy to leave off a 2 if you're not paying attention. So if you want to double check, multiply all of these back together and you should get 104. So now we're going to find our common pairs. So this 2 matches up with this 2. Now we can't match this 2 and this 13 up. They're not the same kind of animal. This would be like putting a horse and a duck together. You can't do that. They're not gonna be friends. So the 2 and the 2 comes out. So I have 1 2 that comes out of my barn. And then this 2 times 13 stays on the inside. And we have to multiply them together because we need to simplify it back down. So 2 times 13 is 26. And this would be the most simple form of the square root of 104. So number 3, negative square root of 48. Now this one's a little different because we have this number out front here. So this is just understood to be a negative 1. So before we do anything with that, we're going to go ahead and factor our 48 down into its factor pairs. Now you can start wherever you want. Some of you might have seen immediately that 6 times 8 was 48. Or 4 times 12. Or 2 times 24. You can do it however you want. So I'm going to do 6 times 8. So neither of those are prime. So 6 breaks down into 2 times 3. And those are both prime. 8 breaks down into 4 times 2. 2 is prime, but 4 is not. So 4 breaks down into 2 times 2. So now that's going to leave me with, the negative has to come down in front. So that's like a negative 1 times, then I have 2 times 2 times 2 times 2 times 3. And again, it's always a good idea to multiply these back to make sure you didn't lose any of your factor pairs. So we have this 2 in common. So that means 1, 2 is coming out for that pair. So we have negative 1 times 2. It's always times. And then here's another factor pair. So we're going to bring out another times 2. And then this guy stays all alone, this 3 on the inside. So that's going to give us the answer, negative 4. You multiply these together times the square root of 3. And that would be the most simplified version of negative square root of 48. Alright, so last one is going to be 2 times the square root of 108. So I want you to try this one on your own. When you think you have it, turn the video back on to check your answer. Okay, you could have used, again, either method to do this problem. I did the factor tree. So you should have gotten that your prime factors of 108 are 2 times 2 times 3 times 3 times 3. So we have a factor pair of 2 here, and we have a factor pair of 3 here. So that means that there's already one 2 outside of the barn, but then we're going to have another 2 come out because of this pair right here. And then we're going to have a 3 come out because of the pairs of 3s. And then left inside is a 3. So when you multiply 2 times 2 times 3, you get 12. So 12 square root of 3 is what you should have gotten as your simplification. So if you got this one right, give yourself a smiley face. If you got it wrong, give yourself a frowny face. And if you have any questions, write them down so that we can talk about them tomorrow.